Tesla's Battery Day has come and gone. It was one of the most anticipated events of recent memory. And I was pretty impressed. I kind of expected as much. I think the hype was over the top. In this episode, I want to break this down and give you all the highlights of what was covered and how it's all going to factor into their future. But before I get started, just a quick moment. I want to say thank you to all of our patrons on Patreon. Your support means so much to us. And if you want to be a rock star supporter of this show, help us make more content more often, consider becoming a patron. And if you're thinking about buying a Tesla, whether it's a car or Powerwall or solar products, use our link. It would really mean a lot to us, help support the show, give us a couple of perks, and you as well. And most importantly, it'll help us get some visibility with Tesla. And maybe the next event we'll be able to attend in person. All right, so let's jump right into it. Part one was kind of the investor portion. Part two was the battery portion. So in the investor portion, they mentioned that the Shanghai factory was built in about 15 months, which is really, really impressive to go from dirt and drawings to a full factory. And if you're a Tesla investor, the Shanghai factory is a huge deal. That is the biggest car market. They were the first new car company in 100 years to build volume automobiles, which is, again, crazy cool. We take that for granted with all the progress lately. Also, 4 straight quarters of GAAP profitability, which means they're S&P 500 ready. That'll probably happen at some point. And they're outperforming every other automaker who's had a tough time here during COVID-19 and all of the stuff going on in the world. But Tesla sales are still up. Elon also mentioned how critical safety is to their design. They make the safest cars ever tested. And interestingly, the Y was not in some of their documentation. It might just be that the data's not out yet. I'll be curious to find out. But they mentioned the X and the 3, which we know are safest in segment. And I'm sure the Y is right there as well. One thing I thought was very insightful, and I'll do an entire episode about this. As a software engineer, I think I have a pretty good idea on what they're struggling with, but their entire FSD software package has gone through kind of a page one rewrite. So I think their platform was hitting limitations, and rather than try to patch it with fixes and small changes, I think they wanted to refactor it, re-architect it, and build it again from the ground up. There's also news about Giga Texas and how they're going to be building Model Ys, which look the same, but they're going to be built differently. All right, so now let's jump right into the heart of the matter, Battery Day. So first, I loved what Elon mentioned about how they gauge success. He mentions that the idea is, I want to measure how much quicker we have a sustainable transportation model. And that's how he gauges his success. And honestly, already today, I think the number is like 20 years. We'd be 20 years ahead of where we would be without Tesla. And that number is only growing. Over 1 million EVs delivered and over 26 billion miles driven, all really cool metrics. The next thing is he jumps right into talking about the current battery output. Currently, Tesla is at around 0.1 terawatt hours of battery output a year. And he says we need to be at about 10 terawatt hours per year. So going from where we are now in the gigawatt hours per year capacity to 10 terawatt hours is a really big jump. And it gets to the heart of one thing I want to make sure that we're all clear on. And that is all the batteries that Tesla is currently buying, whether from Panasonic or LG Chem or CATL, they will continue to do that. Tesla wants to get their hands on every cell possible. If they have more cells, they can make more cars and more Powerwalls and make more money. So they need every cell they can possibly get. And as they project out into 2022, Elon mentioned in a tweet that they're projecting that there will be shortfalls where they're not going to have enough batteries for the kind of scale that they want to build up to. And that is why Tesla building their own batteries in-house is a big deal. To further drive this point home, he mentions that we would need 135 gigafactories like the ones we have in Nevada to make that many batteries. And that just isn't going to happen, just in terms of cost and labor, materials, all the other things that would be needed. That's just not doable. So their goal really is to be more efficient, make more batteries in their factories, make them more energy dense, and all around improve output. So to make a better battery, Tesla has broken it down into improvements in 5 key areas. The first is the battery cell design, the individual cell design. The second is the cell factory, how they're going to build individual cells. The third is the anode materials. Fourth, cathode materials. And fifth, the cell vehicle integration, how it all comes together into the package of a car. Tesla's first batteries in their Model S were 18650, 18 millimeters around and 65 millimeters tall. And that moves over to 2170 when they went to the Model 3 and Y. Now, their next cell is going to be even bigger, and it is a 4680. So that means 46 millimeters across and 80 millimeters tall. This is by far a larger battery than they've ever built before. And there's a lot of good things that happen when the batteries get bigger. You can pull more. So the power density, how much energy you can draw from it at a time, goes up. So Tesla mentions that the real strategy here and the real challenge to bigger batteries is that the heat goes up and you can't have the batteries getting hotter. So how do they solve that? By going with a tabless battery design. Until now, the batteries that they've been going into their cars have a tab on it. What that means is if you were to unwind the battery roll, that the furthest point the electrons would have to travel would potentially be the length of the roll. And now these battery rolls, when you unwind them, could be like 3 meters long or 9 feet. So that means that, let's say the tab is in the middle. Well, then at the furthest point, you'd have electrons traveling half the length of the roll. And if the tab is on the end, you'd have electrons that have to travel the entire length of the roll. This causes higher resistance and impedance, and it also makes the batteries hotter as they operate. The solution to this is to go with a tabless architecture, and they have a spiral tab design. So each roll has a little bit of a tab that overlaps and touches itself. And as a result, you don't have to have a tab at some point in the battery length. All you'd have to travel is the 80 millimeters that the battery is tall. This is really important, and this is what's going to allow them to use this bigger battery and to be able to mitigate the one problem that the bigger battery comes with. From the cell design, step one of their improvement process, they're going to have 16% better range. I think for volume or weight considered equal. So for example, for 1 kilogram of the old cells versus new, you're going to have 16% more range. Second, you're going to have a 6x increase in power. And this is what I mentioned before. This power is really important for high power applications like the Tesla Semi. My car is measured in watt hours per mile. So 250 watt hours per mile means 4 miles per kilowatt hour. The Tesla Semi will be the other way around. It's going to be kilowatt hours per mile. It'll be multiple kilowatt hours probably per mile. So with this new cell design, they're going to have 6 times the power density from each individual cell, which will be great. End result of all this is about a 14% improvement in dollars per kilowatt hour. And that is a huge reduction from just the first step. All right, so now step 2 is the battery factory category. So here there's a couple of things, and they want to talk about the electrode. And this is where the Maxwell technology acquisition really comes into play. I knew this would be a big improvement in terms of floor space and methodology and procedure, and it would help them make more batteries, but I cannot believe just how much of a reduction this is going to result in. Current batteries are created when a wet slurry mixture is added to an electrode, and it is then forced into a baking process, and then it is treated and fixed and finally ready to rock. This new procedure would be a dry coating, and they showed it as a kind of a press. So you put the dry coating material on top, you roll it through a press, and as a result, now you have the dry electrodes completely ready and attached to the current collectors without any baking or anything else. The end result is a 10x reduction in the energy required, all that baking, all the ovens, all that sort of thing, and a 10x reduction in floor space footprint. So that means that in a factory, you only need 1/10 the space you used to need for all of these machines. And as a result, then you could have more assembly lines for battery production. And one thing Elon wanted to make really clear is that this procedure is really difficult. It wasn't like they acquired Maxwell Technologies and it was mission accomplished. They mentioned that they're on their 4th revision of the machine to actually do this dry coating application. And he believes that it might be revision 5 or even 6 by the time this reaches full production. So this is really hard. If it was easy, he says everybody would do it. But the end result of doing this is shocking, and it'll completely revolutionize how they can assemble and put together batteries. They also acquired High-Bar Systems, which will be the battery manufacturing machinery that they're going to employ. And they have already started to improve upon their process and come up with a continuous assembly line to maximize output. And in the entire presentation, my biggest takeaway is that the one thing Elon wants to absolutely dominate on is being the best manufacturing company in the world. He mentions that in a couple of years, everybody will have a long-range EV. That isn't the hard part. He says he wants to be the best manufacturing company in the world. And I think what that really means is that long-term, even if other people start to license batteries from other companies, Teslas will always have the advantage because they are deeply invested in the vertical integration of building their own battery. And as their manufacturing prowess and expertise increases, they'll increasingly widen the gap because they'll have battery costs that are substantially lower than other people. And until a day when they have so many batteries that they're selling it to other customers, that means that they'll have the biggest advantage in the market. The next two categories are anode and cathode material. These are the main components of a battery. And the big takeaway here is that rather than just buying this raw material from some other company, they have plans to build a factory in North America somewhere where they will actually be in the business of producing anode and cathode material, not just buying that from somebody else. So for the anode, clearly the move is to have more silicon, but how to do that is key because solutions like silicon glass or silicon structured in graphite and silicon nanotubes, which is something that people thought they might go with, is all really expensive, and the volume that they could yield would be just too low for the kind of scale that they're trying to build batteries at. So they're going to come up with a custom Tesla silicon, which is going to be very cost effective at around $1.20 or so per kilowatt hour. So as a result, they're claiming about a 20% better range than with their current chemistry for the anode, all while keeping costs really reasonable. Part two, of course, is the cathode. The first key is they wanted to be cobalt free. And the reason why is cobalt is the least ethically sourced of their battery materials. There are concerns with child labor and other concerns that Tesla does not want to be associated with. Plus, it's really expensive. So their new battery is going to be cobalt free. Second, they're going to go with a different tiered approach for their different kinds of applications, which is also really smart. One, for stationary applications, things that don't need to be the most energy dense and lightweight. For example, a Powerwall, which is just stuck to the side of your house, they're going to go with lithium iron phosphate, which is a great chemistry for something like that. And most companies use that. It means really long life and good prices, even if it's not the most energy dense. Second, for their medium range applications like their sedans and their cars, they'll have a nickel and manganese formulation. And finally, for mass sensitive applications like the Tesla Semi, they'll have a high nickel content battery. This will give them the most range and the highest energy density. The big surprise here for me was the fact that they mentioned they're building a lithium and a cathode factory of plant here in North America. So that means they'll take raw materials and they will build it out into the cathode and lithium materials that go into batteries. This is really important because that means they are now in the business of recycling. Because when you handle the entire material supply chain from that level, that means when old packs come in to be recycled, that's actually a cost-saving measure. Because when you have to go mine it, it costs this much. And when you can just grab it from your own battery packs you used to make and break those down into the lithium and the nickel content to recycle, your costs are actually getting better. So recycling isn't even being done for the environment, which it will be. It's being done because it means it'll have the cheapest supply chain possible. And he mentioned that when we reach full scale, meaning when everyone's driving electric, we have batteries everywhere, supply chain will barely even involve mining. It'll all just be recycling. And that's amazing because it drives a nail in the idea that batteries are bad for the environment because sure, we do have to mine them. Once we have them, they can be reformulated and recycled and reused, which is not true about petroleum, for example. Another comment that I've gotten in the past is about lithium mines. There was an idiot on Twitter that I retweeted who said, this is a lithium mine and showed a huge hole in the ground. And it's like, no, that's a copper mine because you don't mine lithium like that. Lithium is actually found in saltwater brine pools around the world. And they mentioned that they actually bought the rights to about 10,000 acres of land where there's lithium clay deposits in Nevada. And one thing Elon mentioned is that there is enough lithium just in Nevada to build all the cars in the entire US auto market. So that goes to show you that lithium is not some rare earth material. It is highly abundant and in great supply. Okay, last but not least is the cell vehicle integration. And what that means is how we go from a battery cell to a completely built out pack in a car. Currently, what Tesla does is they build modules. So they have their cells that they line up, they put their bus bars on them, they put them to series and parallel to the right voltage that they want, and then they put them into packs. And this pack has a cooling ribbon and it attaches to other packs and they're lined up together. All that metal for the pack is metal and weight that isn't giving you any range. So Tesla wants to get rid of that and to reduce all the bits that don't add range and streamline the entire process. How they will do that is with the Gigapress, which is the largest casting machine ever on Earth. And what it will do is it'll build the entire front and back of these vehicles as one huge cast. Currently, there's a lot of different parts that are stamped into the right shape, and they're either riveted or welded, and there's just a lot of parts and a lot of complication. This machine would actually build the entire back end, for example, of these cars in one piece. And they were able to do that because they actually came up with their own alloy of aluminum. The key here is that it doesn't need to be heat treated to be strong. And that is key if they're going to cast the entire part in one go. So now with the one piece casting, the batteries would have a place to be fit in. And he mentioned that the structure that will be used to glue and laminate the batteries to the top and the bottom will all act as structure. So now the batteries and the casing is all part of the structure of the car, as opposed to building a structure with an open area for modules to sit in. And his analogy was to airplanes. Early aircraft had wings that had space for a fuel tank. Later airplanes actually decided, what if we build a wing-shaped fuel tank? And that's kind of what they do. The entire wing is a fuel tank, and it's kind of built into the right shape. That's the approach they're taking with their battery integration into the vehicle itself. So if you factor in 1, 2, 3, 4, 5 all together, the end result is a 57% savings. But that's not all. They're claiming 55% more range. I'm not sure if that is for the same amount of mass or volume, but either way, it's pretty impressive. And a 56% reduction in the price per kilowatt hour at the battery level. Also, the investment per gigawatt hour is reduced by 70%. So that means if they want to go and scale up to 10 terawatt hours per year, that price that would be needed to be spent to reach there has been reduced by 70%. So this is what they're planning to do. And they actually have a battery factory that they're building batteries out of in Fremont. So they have their in-house development. They're going to scale that up. And eventually in 18 months or so, they'll start to ship these in products, maybe the Tesla Semi, for example. And in 3-4 years, there'll be a full-scale production. The one thing Elon mentioned that I wasn't too happy with was that they're not going to support vehicle to grid. And his argument was that that's why you should get a Powerwall. And to my ear, that doesn't sound like the best answer. And the reason is because you have a 100 kilowatt hour battery pack sitting in your garage, and the average car is not used very much. So until we have like robo-taxi networks, most people don't use their cars. And they already have a huge battery pack that could be stabilizing the grid. But I think this gets into the one thing that was not mentioned. I maybe shouldn't have waited till the very end for this, but they don't mention anything about the life cycle. There was no mention of a 1,000,000-mile battery. So that makes me think all these improvements are going to still be closer to the 250 to 300, 400,000 mile range type numbers, and that they didn't maybe quite reach the 1,000,000-mile battery mark yet. But until you have really long life cycles, I think the vehicle to grid would be a problem, because if you're going to stand by a 100,000-mile warranty, you don't want these cars' batteries to be depleted and charged sitting there while they're not driving, because then you'll have to replace more packs and it'll cost you more money. So sounds like a business decision, but we will see. I'll report and make another video in the future if things change there. But the two last things that they mentioned, they're one more things, if you will. First, they confirmed they are building a $25,000 electric vehicle. That will be huge. That is when you compete with the Honda Civic and the Toyota Camry. And that will be the car that they will sell a lot of. So they're not going to build that car until they have enough battery supply sorted out, because they already are battery constrained with cars like the Model 3, which are closer to 45,000. So before they even talk about a $25,000 model, they have to scale up battery production by like a factor of 5 or 10. When they do that, that next generation, more affordable car will come. The second thing is the Model S Plaid Edition. This car is going to be 0-60 in under 2 seconds, have a 200 mile an hour top speed, and it was caught doing laps at Laguna Seca at 1 minute 30 seconds 0.3, which would be like the fastest car, 2-door or 4-door ever tested. It'll have over 1,100 horsepower. Oh, and it will do over 520 miles of range. If these numbers sound interesting, I think they pretty much had the Lucid Air on the board and they wanted to beat it in terms of specs, and I think they have. But what a great time to be alive, to have these different companies with great engineers behind them competing and making better and better products. I think we all win. So that is the announcement. I think their stock went down because, I don't know, they were expecting Tesla to unveil a cure for cancer or something. I'm not exactly sure. The hype is never justified. And that's what I want people to remember about this stuff. This is an engineering company and this is an engineering event. The kinds of things that they're doing are really challenging. I loved that they had engineers on stage talking about the challenges and inviting people to apply to Tesla if you want to work and change the world, because these are challenging problems. And I think Wall Street doesn't typically understand the nature of what some of this stuff is, because I think their stock will take a little bit of a dip for a while because people expected who knows what. But huge announcement, amazing stuff. Did I miss something? Was there more you guys thought about? I'd love to hear from you on this one. If you guys haven't already, I would love if you joined me on Twitter and followed me on Twitter. I'm trying to be more active there. And 130,000 subscribers on YouTube, 800 followers on Twitter. There's a disconnect. Let's fix that. I'd love to be more involved in the community. Join us on Patreon. If you're buying a Tesla, use our link. Thank you for all of your support as always. We hope you're excited about the event and all that is to come. I know I am. Can't wait to hear more. We'll cover some of these topics in future videos in the coming week or two in greater depth. So subscribe and be on the lookout for that. I'm Ricky with Tuba Da Vinci, and thank you so much for watching.